Now that we've talked about observable quite a bit, and we also talked about parallel flowable a bit, so you could do your assignment 5, let's now turn our attention to the flowable class. Recall that parallel flowable is a variant of flowable that adds the ability to do parallel processing. But we really haven't talked much about flowable, and so I'd like to spend a little time on this because it's a very interesting class, and it demonstrates yet another cool feature of reactive streams. In particular, it supports back pressure, and we'll talk about what back pressure is. I asked ChatGPT and DALL-E to generate me an image that represented someone who was under pressure, and that's what it came up with. So I thought that was pretty cool. The clock is ticking, and there's a mountain of work to be done. That's kind of how I feel when I'm reviewing code, except it's not coming in paper form. What back pressure allows you to do in reactive streams is it can be used to ensure that fast publisher or publishers don't generate events more quickly than a slower subscriber or subscribers can process them. And we'll see there's a whole bunch of different ways that that works. So let's talk about the flowable class. First, let's talk about why we need it. So because of the evolution of RxJava, the initial implementation supported something called observable. We've seen that for quite a bit. And that class does not support back pressure. There's no way to keep fast publishers from overrunning the resources of slower subscribers. You just have to suck it up and do whatever. Therefore, an observable can emit a potentially endless stream of elements at a very high rate. And fast publishers or fast publishers can therefore quickly overwhelm the memory and processing resources of slower consumers. If you've ever watched the famous I Love Lucy chocolate conveyor belt in a chocolate factory scene, and if you haven't watched it, you can watch it here at this link. This is a good example of the problem that occurs when things are arriving too fast to keep up with them. So the way it works is Lucy and her friend are in a chocolate factory, and their job is to take pieces of chocolate off the conveyor belt and put them in a box. And of course, the chocolate is coming too fast. So they first are like frantically trying to put things in the box, and it's getting faster, and then they start stuffing the chocolate into their mouths to keep up, and that's what you can see here. She's got chocolate in her mouth. Pretty funny. So that's the metaphor to think about when you think about the issue of flow control and dealing with rates that occur too rapidly. So to address this issue, the flowable class was introduced in RxJava 2.x. Doesn't exist in RxJava 1, but it's in 2 and beyond. I think we're in RxJava 3 at this point. And almost all the operators in flowable are the same as in observable, with a few exceptions. And those exceptions have to do with its support for back pressure. Another fun reference, this is a comic book somehow that is showing off the Queen song, Queen David Bowie duet, Under Pressure, which is pretty funny. So more discussions of pressure. Back pressure aware subscribers using Flowable can inform the publishers how much data they can consume in one fell swoop. And there's a couple different ways to do this. One way to do this is for the subscriber that is back pressure aware and using Flowable to tell the publisher, don't send me more than X number of events before I ask you for the next chunk, the next tranche. So in this case, the subscriber says, hey, I want to deal with 3 of these things, and the publisher will then send it 3 events, and then the subscriber says, okay, I can get 3 more, and so on and so forth. The idea here is to avoid overwhelming the memory and processing resources by ensuring that so-called flow-controlled publishers don't generate events faster than subscribers can consume them. And I asked ChatGPT to generate me an image of a police officer, like a traffic police officer, exerting flow controls, stopping traffic so that you can get a flow more effectively. And that's what it came up with. I thought that was pretty cool. All right, so that's what we're dealing with back pressure. There's also another variant of back pressure. It's not really back pressure, it's more flow control, where non-back pressure aware subscribers can apply an overflow strategy if they can't keep up with faster publishers. And there's a bunch of strategies, the back pressure strategies, for dealing with this. And we'll talk about them. One is to buffer everything, which just postpones the inevitable. If something's occurring faster than you can keep up with it and you buffer it, eventually you'll run out of memory. But if you have bursts of data that don't exceed the amount of memory, that's a good option. We'll see that there's some other strategies like drop. It says, hey, if too much stuff comes in, just drop everything up except for the most recent value. Sorry, it drops the most recent value if the downstream can't keep up. That's kind of like Lucy, where and her friend in the chocolate factory, they would, basically, if things were going too fast, they just throw the chocolate in a trash can. There's also an error back pressure strategy which says when we start missing stuff, throw an exception, say we can't keep up. There's also one called latest, which is a little bit like drop, except it only keeps the latest value and it overwrites any previous value. And then missing, which says on next events are written without any buffering or dropping. And I'm not really sure what that exactly does. That's another good question we should ask ChatGPT. What does missing do? So these strategies, these non-back pressure aware subscriber strategies, are designed for non-flow controlled publishers. So the publisher is still going to generate the events as fast as it can, like Sonic the Hedgehog racing around through the game. But the subscribers now have defined strategies for dealing with the case where the publisher is generating data too fast. So let's talk about these strategies in a bit more detail. So the way this works is there's a create operator on a Flowable, which can be used to indicate not only where the data comes from, but also the back pressure strategy, what's called the mode. And it's the second parameter here to create that's used to specify the mode. So here's an example where we're going to provide basically an emitter strategy where we're going to go from 1 to some count, and we're going to subscribe this, and we're just going to emit random numbers as fast as we can. So this particular, it's just a little lambda expression. If I was actually writing real code, I would make that a method reference instead of a lambda expression or some other variant that's a little bit cleaner, but I'm just trying to show how you can spit out a bunch of data quickly. And then the back pressure strategy will, in this case, ignore the items that can't be processed immediately. So keep dropping the ones that come in that are not able to keep, where the subscriber can't keep up. Notice that this operator, this create operator on Flowable, is different from the create operator on observable. The create operator on observable takes this lambda expression-like thing, but it does not support a back pressure strategy. There's just one parameter that it supports. You can also use other Flowable operators in order to be able to apply the back pressure strategies. So here's an example. Let's say that you had something that was generating mouse moves, and if the mouse was moving faster than the system could keep up with it, it'll just basically drop the items that can't be processed until you slow down the mouse movement and you can deal with them. So you can use the on back pressure drop. You don't have to use create. You can use this in any Flowable stream. In this particular case, notice how we're going to apply the back pressure, and then this will run in a computation thread, and that will do some movement of the mouse on the screen. There's also on back pressure buffer, which can create a bounded or unbounded buffer that holds the emitted items that couldn't be processed. So in this particular case, we're going to generate 1 million values, and then we're going to have a back pressure strategy here, and that will buffer up to 16 items, and then it'll drop it if it'll drop the oldest one if it can't keep up with that. And then on back pressure latest is like the drop strategy, but it keeps the last emitted item as opposed to discarding the most recent item. So same kind of thing. You can have mouse clicks, and you're going to only keep the latest one. Same kind of idea. So that's an overview of the Flowable class and some of the strategies that it supports.